Hi, and welcome to this video on graphing linear equations. In this video, we're going to quickly review the various ways that linear equations can be written and discover the best methods of graphing equations by hand based on the form that you are given. Let's get started. When graphed, linear equations form a straight line on the xy coordinate plane. The graph is a visual representation, and it is often useful to identify key features that are not immediately recognizable from the equation. For example, when we look at a graph, we can see exactly where a line crosses the x-axis. This is useful because that x value is the solution to the equation. Similarly, if we are given a system of equations, meaning one or more equations, we can find the solution of the system by graphing each line and finding the point of intersection, if it exists. Knowing how to graph a linear equation by hand is an important skill. The graphing method that you will use will depend on the structure that is provided. Let's quickly review the three forms. An equation in standard form is written as ax plus by equals c, where a, b, and c are constants. A and b are known as coefficients of the variables x and y respectively. An equation in slope-intercept form is written as y equals mx plus b, where m represents the slope of the line and b represents the y-intercept, which is the point on the y-axis where the line crosses. An equation in point-slope form is written as y minus y1 equals m times x minus x1. This form provides the ordered pair of a point, x1, y1, that the line passes through and the slope of the line. While the equations may look different, they all represent a line. When you are asked to graph an equation, you will want to choose the method that is most suitable based on what is provided. Let's now take a look at each form and determine the graphing method that is best for each. Let's start with an example that uses standard form. Ax plus by equals c. A few algebraic steps are necessary in order to graph a line in this form. Keep in mind that you only need 2 points to graph a line, and using a straight edge to carefully draw the line through those points will provide more accurate results. The 2 points that can be quickly calculated from this form are the x-intercept and the y-intercept. The graph here illustrates this process visually. Let's go through the steps to find the intercepts of the equation. 2x plus 3y equals 12. The y-intercept can be determined by substituting x equals 0 into the equation and solving for y. 2 times 0 plus 3y equals 12. 0 plus 3y equals 12. Divide by 3 on both sides. Because the 0 doesn't matter, it won't change anything. And you're left with y equals 4. The line crosses the y-axis at the y-intercept 0, 4. Likewise, the x-intercept can be determined by substituting y equals 0 into the equation and solving for x, as follows. 2x plus 3 times 0 equals 12. 2x plus 0 equals 12. Divide by 2 on both sides, because again, the 0 won't change anything because you're adding it. X equals 6. So the x-intercept is at the point 6, 0. Once the intercepts are plotted at the points 0, 4, and 6, 0, you are ready to graph the line. The line passes through these points, and arrows at the ends should be drawn to indicate that the line extends forever in both directions. This is an easy method of graphing an equation in standard form if the constant c is a multiple of the coefficients a and b. Accordingly, this method of graphing is called the intercept method. Let's try another example problem. Graph the equation 3x minus 4y equals 12. This equation is in standard form, and the constant 12 is a multiple of both 3 and 4. Therefore, using the intercept method to graph is a good method. As before, determine both the y and x intercepts. To find the y-intercept, let x equals 0 in the standard form equation and solve for y as shown. 3 times 0 minus 4y equals 12. 0 minus 4y equals 12. Divide by negative 4 on both sides, and you get y equals negative 3. So our y-intercept is at the point 0, negative 3. The x-intercept can be determined by substituting y equals 0 into the equation and solving for x. 3x minus 4 times 0 equals 12. 3x minus 0 equals 12. Divide by 3 on both sides, and we're left with x equals 4. This means our x-intercept, or the point where the graph crosses the x-axis, is 4, 0. So our 2 points we're going to use to graph are 0, negative 3, and 4, 0. Graph this line by plotting the intercepts and drawing a straight line extending through the points, like so. Okay, now let's try slope-intercept form. Y equals mx plus b. If you're given a standard form equation but the constant c is not a multiple of the coefficients a and b, then converting the equation into slope-intercept form will provide the information needed for a more accurate graph. To convert to slope-intercept form, simply solve the standard form equation for y. Consider the standard form equation 3x plus 2y equals 4. You notice immediately that while 4 is a multiple of 2, it is not a multiple of 3. A better way to graph this line is to first convert it to slope-intercept form by solving for the variable y. To do this, we take our equation 3x plus 2y equals 4 and subtract 3x from both sides. This gives us 2y is equal to 4 minus 3x. Now we want to divide by 2. When we divide the whole equation by 2, it's also the same as dividing each part by 2. So we're going to do y equals 4 divided by 2 is 2, minus 3x divided by 2 is negative 3 halves x. Now this equation looks similar to what we want, but it's not quite right. We want our x to be in front. Since we're adding, we can flip this without worrying about changing anything. So y equals negative 3 halves x plus 2. The resulting equation y equals negative 3 halves x plus 2 is in slope-intercept form, where the slope of this line is shown as m equals negative 3 halves. The constant in this equation, b equals 2, represents the point where the line crosses the y-axis, the point 0, 2. To graph a line in this form, plot the y-intercept at 0, 2. A second point on the line is plotted by moving in a vertical direction, often referred to as the rise, and then a horizontal direction, referred to as the run. These directions are known by looking at the slope, m equals negative 3 halves. Because the numerator of the slope is negative 3, move 3 units down from the y-intercept. From there, move 2 units to the right as indicated by the denominator of the slope, 2. Note, a positive rise will be up and a negative rise is down. A positive run is right, and a negative run is left. This movement from the y-intercept brings you to another point that is on the line, 2, negative 1. With 2 points plotted, you can graph the straight line that extends through them. Now let's try this out with another example problem. Graph the equation y equals 2/3 x minus 1. This equation is already in slope-intercept form. The slope is identified as m equals 2/3, and the y-intercept is at the ordered pair 0, negative 1. That is where the graphing begins. Plot the first point at the y-intercept, then move from that point according to the slope. Both numerator and denominator are positive, so the rise is up 2 and the run is right 3. This brings you to the second point that is needed to graph the line, 3, 1. Carefully draw a line that extends through these 2 points. Okay, now to our third and final form, point-slope form. Y minus y1 equals m times x minus x1. As noted, the point-slope form of an equation names a point, x1, y1, that the line travels through. It also provides the slope. So graphing a line in this form is similar to the process we detailed before. The exception is that rather than starting at the y-intercept, the first point of the graph is at the point x1, y1. Identifying that point sometimes causes some confusion. Note that the point-slope form subtracts the y-coordinate of the point y1 from the variable y, and the x-coordinate of the point x1 is subtracted from the variable x. Notice how the point is identified with the following examples. In this first example, the line passes through the point 2, 3. The line in the second example runs through the point 1, 2. In the third example, the line passes through the point 7, -5. Example 3 requires some explanation because the y-coordinate of the point is added to the y variable in the equation rather than being subtracted. As a result, an adjustment must be made to the equation to identify the point. Remember, when you subtract a negative value, it has the same effect as addition. As a result, rewriting the equation to reflect subtraction is allowable. The adjusted equation looks like this: y minus -5 equals 3 times x minus 7. Now the point x1, y1 is recognizable as 7, -5. Here's another example of a point-slope equation that deserves some attention. Y equals 12 times x minus 4. This equation is unique because there is no y-coordinate being subtracted from the y variable. To identify the point, rewrite the equation as y minus 0 equals 12 times x minus 4. Now the point can be seen as the x-intercept, 4, 0. Now that the first point can be identified from point-slope form, use the slope to move from that point to another point on the line. Okay, let's go over 2 more examples. Graph the following equation: y minus 3 equals 4 times x minus 2. Identify and plot the first point, 2, 3. Slope is m equals 4. This value can be represented by the equivalent fraction 4 over 1. This slope translates to a rise of up 4 and a run of right 1. This brings you to another point on the graph, 3, 7. The line can then be graphed extending through these 2 points. Graph the following equation: y minus 2 equals -1/3 times x minus 1. Identify and plot the first point, 1, 2. Slope in this equation is a negative. At this stage, you can decide to move the rise or the run in the negative direction. For this example, let's consider the rise, or the numerator, to be the negative value. M equals rise over run, which equals -1 over 3. This translates to a rise of down 1 and a run of right 3. The position of the second point on the line is at 4, 1. The line is graphed by drawing a line extending through these 2 points. Now that you've had some practice identifying the features of linear equations in various forms, you can recognize why there are different graphing methods. A quick analysis of the equation should give you direction on how to proceed with the graphing process. I hope this review was helpful. Thanks for watching and happy studying.